Hi friends, this is Rakesh Kuchana. So in this video we will understand what is race condition and how can we resolve it in different ways. Okay, so the first thing is we need to understand what is race condition, and the second step is we need to understand how can we resolve it. So resolve it means definitely race condition is an issue. Okay, so in order to understand race condition we need a sample program. First we will write a sample program and we will see what is the issue, and then we will understand what is race condition, and then we will resolve it in different ways. Okay, come on, be ready. So first what we will take is we will take one class. Okay, let's say class counter. Okay, so it will have a counter variable. It will have a counter variable. Okay, let's say private int counter variable, or let's say count variable. Okay, count variable. Okay, so I will add just one method to increment the count. Public void increment, so always increment by 1. Okay, and to read the count, sorry, this is count, right? Yeah, to read the count again I will add one more method, get. So we will use Eclipse, generate getters and setters. I want getters, yes, I want get count. So this is a small counter class. So let's imagine this is a class, not only counter. In real time scenarios we will have different types of classes, right? So this is a okay, but in this example we will see what issue we will face with this when it is used in multi-threaded environment. Okay, so we will see now. So let's say my goal is, I have a requirement, okay, to increment this count by 2000, let's say. Okay, let's say I want to increment this count by 2000 times. That means 2000 output I have to get. So directly I can do that, right? What I can do directly, I can add for loop, and 2000 times I can increment this, 2000 times I can call this increment method. So it will increase this 2000 times, but it will take some time, right? So what I want to do is I want to do this using multiple threads, so that it will reduce the time and it will improve the performance. So I want to utilize the CPU here. Okay, so for that what I will do is I will create two threads to do this. Thread T1, okay, new thread. Okay, and this thread will take runnable interface, right? So that's the functional interface. I can pass a lambda expression here to provide the implementation for the run method. So what we can do here, we can increment the count, right? So for int I is equals to 0, I less than or equals to 1000. So 1000 times I want to increment in this with this thread I plus plus. Okay, so we need what here? We need the object for counter, right? So what we will do is here itself I will create private static, okay, counter equals to new counter. Okay, I will create the instance of it. Okay, if I want I can create the constructor also for initializing it. So I will create one constructor also here, constructor generate, constructor using fields generate. Okay, using this constructor I will initialize to 0, let's say. Okay, now I want to increment, right, this one. So I will use this here. I will call increment method. Done, right? So similarly I can create one more thread T2, and this will also do the same. So the same object I am incrementing it 1000 times with this thread, 1000 times with this thread. So the final output should be what? 2000, right? So first of all we need to start the thread, right? So t1 dot start, t2 dot start, so they will be executing parallelly. Fine. So now, so I want to print so counter value is, okay, so counter dot get count, right? So here if you observe one thing, the main is the main method, the main class is also one thread will be created for this, right? So 3 threads will be there. So if we do like this, before completing these 2 threads, this statement will be executed, so we may not get the correct value. So what we will do is, we will wait for these 2 threads to complete, then we will continue our execution. That means the main thread should wait for these 2 threads to complete their execution, then it has to print these 2, I mean this statement, right? So for that what we can do, we can call join method on each thread, right? So this join, we need to either throw the exception, or we need to handle the exception. So we will surround it with interrupted exception. I mean, you know, whenever we use join method, we will get interrupted exception. So what we will do is, in this block itself we will wait for thread 2 also. So we can wait for 2 threads, then we can print the value. Okay, so this is how we have implemented successfully. So can we execute and see the output? Okay, so we have to get the output as 2000, but we are getting 1567. Okay, are we getting the same output always? Let's run and see again. Okay, 1310, 1386, 1351, 1620, 1111, 1323. Oh my god, I'm not at all getting 2000. Oh my god. Oh, one time I got success case. Wow. So why we are getting these different outputs? Unpredictable output. This is called unpredictable output, unpredictable behavior at all. So what is happening here? So this is called race condition, you know. So race condition. So what is happening here? We will understand. Okay. If you see here, so okay, we have one count variable. So each thread is coming to here, each thread is coming to here, each thread is coming to here and incrementing it, right? So what is happening here is, if you understand, let's say we will have different types of scenarios how thread will interact with this object, right? Let's say thread 1 got the variable. So normally how it will do, you know, this count, how it will be incremented? First of all, it will read the old value, then it will increment it, then it will put it back to the same variable with the new value, right? That is how it will work. So let's say thread 1 reads the value as 0. Let's say currently the counter value is 5, let's say. Okay, counter value is 5. Okay, so reads the counter value as 5. Okay, and increment it by 1, then put it back, right? Then it will, the value will becomes how much? 6, right? So this is how it will be done. So similarly thread 2, by the time thread 2 does it, the value will be 6, right? 6, and increment it by 1, it will become 7. Again if thread 2 comes back, this is for thread 2. So if thread 1 comes, again what it will do, it will increment it by, let's say first it reads the counter as 7, it will increment by 8. So maybe if they execute like this, that is fine, we will get the expected output as 2000 very fast, right? But what if they try to access that variable concurrently? Let's say thread 1 reads the counter value as 5, and before incrementing it, thread 2 also reading the value as 5. Then thread 1 increments it by 1, then the value will become what? 6. Then thread 2 what it will do? Again thread 2 also has to increment whatever it got. What it got? 5. Then the value will become 6 only here also. See, here two counts are done, but it incremented by only 1. See, here 3 are done, 3 times it got incremented. But here 2 times, if you see this 2 times, counts are gone already, because it has to, this loop has to be executed 1000 times and this loop has to be executed 1000 times, right? But out of those 1000 times, 2 times, for 2 times it has to increment to 7, but it got incremented to 6 only. One count got wasted, right? So if this happens repeatedly, definitely it won't reach 2000, right? If this kind of situation occurs multiple times in this 2000, that means 1000 iterations here and 1000 iterations for thread 2, this count won't reach 2000, right? Because it has, ideally here it has to reach to 7, right? But here what is happening? Only it is reaching to 6. So this is the issue we are facing, right? So thread 1 and thread 2 are competing each other to get the value and then increment it. So they are participating in a race to get the value and increment it. But whoever wins the race, they are able to increment it successfully. If the race is tied, then this kind of situation will come, because they same at the same time they got the same value and they incremented to the same value. But here thread 1 wins the race, so it is able to increment it successfully. Here thread 2 wins the race, so it is able to increment successfully. So they are participating in a race to access the object to increment the value here. So this is called race condition. So what is race condition? So whenever a resource is shared and accessed by multiple threads, so here what is the resource here? The counter object is a resource here. The counter object is a resource here, and that is a shared resource here, right? Shared between multiple threads. So this because of multiple threads, we are unable to expect the output. We are unable to predict the output because of the race condition, right? So race condition occurs whenever there is a concurrency. In this kind of situations, definitely we will see race condition. So when multiple threads try to access the same shared resource and try to update the same shared resource, then we may run into race condition. So we need to handle very carefully these kind of situations. Okay, my thought is good. I want to use multiple threads to increment this count. Then my thought is good, because to increase the performance, but I am running into some unexpected output because of the race condition. So this is called race condition. So how can we solve it? How can we solve it? So we can solve it in multiple ways. Let's check how can we solve it. Okay. So we can solve it in multiple ways. We can resolve race condition in multiple ways. How can we do that? The first one we will see, okay, using synchronization. That is, synchronized keyword is there, right? We can use that. And another way we can do is, use it, reentrant lock, using reentrant lock class. This one you can use. Then another way is we can use atomic variables, which are available in the concurrent package. For example, in this case we can use atomic integer. We can use thread safe thread safe collections. Example, here we can use concurrent hash map to resolve this issue. And also we can use, in case of if the counter is immutable, if we make it immutable, we can use immutable also. And the last case, if we want to we can do thread confinement. That means we can split that counter into multiple counters, and we can calculate on those two counters, and we can sum them at the end. That is, let's say, thread confinement. That means each counter is confined to a single thread. That means each copy of counter. So this is how, this is one way, and we have different ways of doing it. Okay, we can think of several ways also, but these are the important ways. Especially we can use synchronization, reentrant lock, atomic variables, thread safe collections. We can use immutable objects, and this way we can implement different ways to resolve the race condition. Are you interested to know how we can implement? Get ready. Synchronization. Yes, whenever there is a concurrency issue, we will think of synchronization, right? So let's implement. So what I will do is, I will just create one more class here. This is synchronization demo, right? Synchronization demo. So what I will do is, I will just copy this issue, whatever the code block is there, right? I will just take this, paste over here, and I will take this class also. I'll just paste here. Yes. So what issue we are getting here? Already defined. Okay, it is already defined, right? I can remove from here, no issues. We'll do one thing, we'll create a separate counter class. Okay, and what I will do is, I will put this there. So it is a public class. What is the issue here? Okay, fine. Okay, so let's say if I make it synchronized, that means if I apply synchronized here keyword, that's it. We have fixed the issue. Can you see that in action? I am getting 2000 as the output, right? Let's run it multiple times. 2000, 2000, 2000, 2000, 2000, right? Perfect. We are able to resolve the race condition using synchronization. Congratulations, we fixed the issue. So this is one way of doing it. Okay, but here there is a problem. Using synchronized keyword, the objects are blocked. That means the threads are blocked here. That means, you know, right, how it works? Synchronized. So each thread has to wait for the other thread to complete its execution. Let's say if you want to complete this method execution, the other thread has to block. Let's say thread 1 reaches to increment this, then it will lock the entire object. After locking the entire object, it will increment it. Then once the object is locked, the other thread cannot access this object, right? It cannot increment it again. Once it releases the lock, once incrementing this, it releases the lock, and the thread 2 will get the opportunity to call this method again. Again it will block that, it will lock the object and it will increment. Thread 2 will lock the object and it will increment. So this is a repetition process. So each thread will get the lock and it will increment. This is how we are providing thread safety, right, on this object using synchronized keyword. But with this, what is happening? Performance is getting down because the other thread has to wait for the second thread has to wait for the first thread has to wait for the second thread. The waiting period, if there is a waiting period, then there is a performance issue, right? This is one drawback is there with the synchronized keyboard. So anyway, this is one way to resolve the race condition. Okay, and we will go to the second one, reentrant lock. So what we will do is here demo reentrant lock. What I will do is, in the counter I will remove this synchronized. Okay, and here I will just copy the same code here. So this is for demo reentrant lock. Okay, so here we have a class called reentrant provided by Java. Let's see how it works. Okay, let's create an instance for reentrant lock. Reentrant lock equals to new reentrant lock. So the advantage of using this reentrant lock is, if we call a lock method on this, we can programmatically lock the object, we can programmatically unlock the object. So we can perform certain portion, we can execute certain portion of the code with thread safety manner. Okay, for example, here this portion of the code, what I can do is I can lock. Once I lock this portion of code using lock method, then it will be locked. Whatever the statements are there under this lock method, all will be locked by this particular thread. So other thread cannot execute the same portion of the code. For example, here this particular increment method on the counter object, I am locking it and I am unlocking it again here. Okay, the same way I will do here. So what I am doing, each thread is locking this particular way, this particular portion of the code, then it is unlocking it. So what will happen? This object will be locked again here also, right? So this method execution will be locked here, right, by the reentrant lock. So if thread 1 executes, it will lock and increment. If thread 2 executes, it will lock and increment again. Very nice, right? So this way also we can control it. So this unlock should be done, otherwise there will be a problem, right? So what we will do is, I will keep this code in try and finally, so that always will make sure that the object is unlocked. Okay, finally this way. So this part we can copy over here, but a code duplication is there, right? We will do one thing, we will create a separate method for this. Okay, refactor extract method, and here we call it as increment. Perfect, right? So we are good. So is it resolving the issue? We will check. Okay, okay, first we will right click, run as Java application. So we are getting the output as 2000. Yes, we are getting the output as 2000 always. Any number of times if you click, we are getting the output as 2000 only. So reentrant lock also resolving the issue, race condition issue, right? So this is how we can use the reentrant lock. Okay, now the next way is atomic variables. again we will create a class to demo it. Demo atomic variables. That means I am taking here atomic integer because we are incrementing the integer, right? Demo atomic integer. So I will take the old code, I will paste it here. Yeah. So atomic integer. So for this we need to modify this one, because this count variable, this count we need to make it as atomic, so that it will provide thread safety. So we need to modify this counter class. Okay, what we can do is, instead of declaring like this, private atomic integer count is equals to new atomic integer. We have a constructor with integer as argument. Okay, we can initialize like this. And how to increment this? We have a method. Okay, we have a method to do that. Okay, here what we can do is, okay, let it be like this, and here what we can do is, we will initialize this here. Okay, we will do one thing, we will initialize this from outside. We are initializing, right? Here also we will, what we will do is, we will initialize like this. Okay, now we have to increment this, right? How we can increment using atomic integer is count dot increment and get. With this we are able to increment it. Okay, so how to return? Get, we have a get method on this, so it will return the value. Okay, if you are able to modify like this, it will provide thread safety again. It will resolve the race condition. Can we see that in action? Okay, so here what I have to do? The same counter. I have not changed anything, right? Everything is same. Let's run it. $2000. Can we run it again? 2000, 2000, 2000, 2000. Yes. So what is this atomic integer? It is performing well. Nice. Atomic integer is also provided by Java in concurrent package for thread safety only. This is also purpose of thread safety. Whenever we want to modify the primitives like integer, double, anything, we have corresponding atomic classes. Okay, so what we can do is, using this we can provide thread safety especially. So internally how it works, you know, it doesn't use synchronized method internally. It also won't block the other thread. Let's say thread 1 is accessing this, thread 2 will not be blocked. So internally they will use some kind of swap algorithm that is also by hardware. So it is something internally, it will do some magic, and it will use some kind of swap algorithm. It doesn't block the threads, it doesn't use synchronized method. Okay, so that's how it will improve the performance also, because it is not using the synchronized method internally. So it will increase the performance also, and it is also providing concurrency. So if you talk about in this such particular situation, if you choose between synchronized and reentrant lock and atomic integer, I would prefer atomic integer, because it is not blocking anything. Internally it is incrementing faster way. What you can do is, as an exercise, you can print the counts, you can print the time, and you can see the performance also between these three, which is performing faster to reach it to 2000 count. Or you can increase the count also, some 10,000, 20,000 like that, and you can see the performance, and let me know in the comment section which is performing better. Okay, yeah. So this is the way using atomic integer. Okay, now thread safe collections also we can use, that is using concurrent hash map. So if you know already, you can just forward the video, but I want to explain to the people who doesn't know using concurrent hash map. Okay, to resolve this race condition issue. demo concurrent hash map. So using this also we can resolve the issue. How? For this, again we need to change this. We need to store the value in the hash map. Let's say we have a key called counter, and in that if we have the value of the count value, then we can use the concurrent hash map here. That means we can wrap the count with hash map, concurrent hash map. How can we do that here? Okay, let's change it. Okay, yeah, private map. Okay, private map string comma integer let we call it as counter or count, anything should be fine. So we will initialize it. While initializing it, what we have to do, new concurrent hash map we have to create, right? New concurrent hash map we have to create. After creating, let's put count dot sorry, this is int count, right? So I want to allow them to initialize to some value, right? So what we'll do is, this one we will take it as, okay, this dot count will take this dot count dot put string can be, I will make it as counter, and here the value should be whatever they are passing. Okay, it is count. Okay, this count it will consider. Okay, so this is done. Now I have to increment it. When they call increment method, what I have to do, I have to increment it. How can you increment it? So how can I increment it is, count dot get, no, this is not the way, right? Count dot compute if you use, if you pass the key, what is the key we can pass here? Counter, and here we can pass how many number of times you can increment here. Okay, anyway, here what we will do is, compute counter, and we can pass by function here, right? By function key comma value, and here value plus 1. So what it will do is, it will increment the count, whatever the values are there, it will go on incrementing it, right? In the for loop, if you put it in for loop, what will happen? It will increment the value by 1, right? For this key, how many values are there, those many will be incremented by 1. Now get count. So this count dot get value we have to return, right? What is the key? So if you pass the key, we will get the value. So this is how we can implement, right? Now let's run and see. Again the same code we can run, right? No need to change it. No need to change it, right? The same code. $2,000, right? So any number of times you run it, you will get 2,000 only, right? So this is how it is working. Now I am using what? I am using concurrent hash map. If you change it to hash map, I will show you that, and we will see the difference between hash map and concurrent hash map. Okay, just we will see. Okay, just for testing purpose. Say I am getting invalid results like 111177, 1235, 1134, 1524, 1217, 1500. Yes, this is what we need to understand. So I am changing it to concurrent hash map. So I am not changing the original code anyway here. This class I am not changing, so no need to, I think no need to create this many classes, right? Yeah. Okay. Anyway, so this is I think this is atomic integer. Yeah, I am running the atomic integer only, right? Yeah. Fine. Anyway, it is actually using the concurrent hash map only, right? Yes, because we changed the counter to use concurrent hash map. We are good. Okay, now what next? Immutable. So if we make this counter as immutable counter, in that case also we can modify, I mean we can resolve the race condition issue if it is immutable. How? This is very important, because if we go to some legacy projects, we can see some immutable classes already there. In that case, if you face this kind of situation in multi-threaded environment, how can you do this? Okay, that's why here what I will do is I will copy this counter class to change it to immutable counter, let's say. Okay, let's say you have gone to one project where you see the object as immutable, class as immutable class. So in this case you want to use multi-threading, you want to use multiple threads to increase the count to 2000. So how will you approach is the question. Okay, so okay, here I want to modify this again back to the same count int. Okay, so to take the count, and here increment means what? We can simply increment it, and here we can return the count, right? Bracket is missing here. Okay. So immutable counter, is it immutable? No, right? So in a video we have done previous video, right, on how can we create our own immutable class. So this is how we have created, no, right? So how we have to create? So we have to return the new instance of immutable counter always if you try to increment it. Okay, let's say increment it. So I am trying to increment it, so always I have to return new immutable counter, new counter class, because this is how immutability means what? We cannot change the object. If you try to change the object, it has to return new object with the changed content, right? So here what is the changed content? I have to increment it by 1 always. When I say increment, with the incremented value I have to get the new counter. So this is how immutable class will be created, right? So this is immutable counter. So now in this case, how we can use multi-threading to improve the performance to reach the count to 2000. So now let's create one class now, demo immutable counter. Yes, we'll copy this. Now let's make it as immutable counter, okay, initialized. So now this is one immutable counter, but on one immutable counter, can multiple threads can perform actually? No, they cannot perform, because it is an immutable object. So that's why we need to create two immutable objects. Okay, so because they are immutable in nature, so what I have to do? I have to split them. I have to definitely split them. I have to split them, and counter 1 and counter 2, right? Then counter 1 is equals to counter 1 dot increment. Why I am assigning? Because for each change it will create a new object, so that object I want to assign it back to here, so that next time I will use the new object, right? So that's why I am doing like this. Here it is counter 2, right? So but here the total sum I have to do, I have to accumulate the results, right? Counter 1 plus counter 2, counter 1 dot get count, counter 2 dot get count, right? Let's run and see. 2000, 2000, 2000. Demo immutable counter only, right? I am running. It's 2000. So any number of times you run, you will get the 2000 only. So if you see an immutable class, and if you want to apply, if you want multiple threads to access that object simultaneously, then this is how we need to approach, because these are immutable objects. You know, immutable objects are also thread safe now, because immutable objects we cannot modify. Definitely it will create a new object altogether. Can you see some disadvantage here? Can you think of some disadvantage of using immutable? Here the disadvantage I see is it is creating so many objects for each increment. Here it is creating 1000 objects, here it is creating 1000 objects. So 2000 new objects are getting created for each increment in the heap memory. Then for what, anyway, the remaining, for example, that if it is creating a new object, means the old object is being unreferenced, so it will be anyway destroyed by the garbage collector. That is fine. But still we are creating, when we don't know, right, when garbage collector will come and collect it. But anyway, when we run this program, we are creating 2000 immutable counter objects. Remember this. This is one lag. This is one disadvantage I can see. Yes, you need to think of advantages and disadvantages whenever you implement something, right? So keep this in your mind when you deal with immutable objects. Okay. So this is one way to resolve race condition, right? So what is the other way? Thread confinement. So this is nothing but just having same like this, we have to maintain two separate counters. So we can say here this is also thread confinement only, because if each counter I have a separate copy, and each thread is executing on each copy. Let's say here this is one copy, this is another copy, and I am performing on, that is one thread is performing on one copy, right? Thread 2 is performing on one copy, thread 1 is performing on other copy. So this is nothing but thread confinement also we are doing here. When we are using immutable counter, we are also using thread confinement here. Otherwise what we can do, we can also clear some class, demo class, to see it other way. Demo thread confinement. Okay, so I can copy this, paste this. So here what I have to do is, I have to take two counters separately, because they are not thread safe, right? Counter 1, counter 2, like this. So counter 1 dot increment, counter 2 dot increment, and at the end what I have to do, I have to collect the results. Counter 1 dot get count, counter 2 dot get count. Right, what I am doing, I am doing thread confinement. So each copy of the counter, I am allowing each copy of the counter to be accessed by one thread only at a time, right? So I am using one thread for this first counter, I am using another thread for second counter. Let's run and see. 2000 only we will get, because they are independent, right? Now these two are independent. Now these two are independent, so they are not shared resources, right, anymore. Because these two are independent counters. But anyway, we are achieving our 2000 count here using the counter, but we are splitting it. This is also one solution, we can say, but I don't prefer this solution. Anyway, I prefer atomic integer or reentrant lock. We have our concurrent hash map. So this way we can go to different approaches. Okay, anyway, congratulations. Today you learned what is race condition and how to resolve it in different ways. In process of resolving it, we understood the importance of what? We understood the importance of synchronized keyword, reentrant lock, atomic variable, atomic integer, concurrent hash map, and immutable objects, right? So we understood the importance of these 5 while resolving the race condition. Congratulations, all the best. Please subscribe for more videos. Okay, thank you, bye bye.